Good morning students. Today I will teach class 9 chapter 8, that is motion. In previous lecture we had studied about the different terms that are related to motion and distance and displacement. In today's lecture I will discuss about the graphical representation of motion and some other terms like speed, velocity, acceleration, which are related to the motion. So first is speed. So speed is rate of change of distance, which means the distance travelled by body per unit time. Here speed is equals to distance upon time. So distance is a scalar quantity. So that's why speed is also a scalar quantity. The scalar quantities are those which have only magnitude but no direction. So as speed is a scalar quantity. The SI unit of speed, unit of speed is meter per second. How we get? So unit of distance is meter and unit of time is second. So SI unit of speed is meter per second. If we calculate average speed of a body, then it is the total distance travelled by that body upon total time. So it is the average speed of that. So for uniform motion is if equal distance covers in equal interval of time. For uniform motion, speed of an object remain constant. On the other side, for non-uniform motion. So non-uniform motions are those if a body covers unequal distance in equal interval of time. Then the speed of the body is variable. Variable means it can be changing because as distance changes, speed also changes. So related to speed, the next term is velocity. So velocity is rate of change of displacement. So velocity is depend upon displacement. As speed is equals to distance upon time, similarly velocity equals to displacement over time. So displacement is vector quantity. And we had studied about displacement in previous lecture. So displacement upon time. Displacement is vector quantity. So velocity is also a vector quantity. The unit of velocity is similar, that is meter per second. So how we calculate the average velocity? So the average velocity of a body is initial velocity. Here I am representing with u plus final velocity divided by 2. So the average velocity is calculated as. So this is for the uniform motion. Displacement is positive, negative or can be 0. So similarly, velocity can be positive, negative or 0. So velocity directly depend upon displacement. So displacement is vector quantity. So velocity is also a vector quantity. Displacement can be positive, negative or 0. So similarly, velocity can also be positive, negative or 0. So next term is acceleration. So acceleration is rate of change of velocity, which means A is acceleration is change in velocity. What does it mean? That is starting velocity is different and the final velocity is different. What change comes out to? That is final velocity minus initial velocity upon time. That is acceleration. So acceleration is v minus u upon t. So unit of velocity is meter per second. And what is the unit of this time? That is also second. So what we get? Meter second per second square. So it is meter per second square. And acceleration is also a vector quantity because it depends upon velocity. Velocity is a vector quantity. So acceleration is also a vector. Here point to be noted, v minus u upon t is the acceleration. If v is greater than u, that is v is greater than u, then the result is positive acceleration. If v is less than u, then the result is negative acceleration. So the negative acceleration is called retardation. So acceleration is of three types. If v is greater than 0, then it is called positive acceleration. If v is less than 0, then it is called negative acceleration. If v is equal to 0, then it is called zero acceleration. So here point to be noted for the conversion factor, that is kilometer per hour is changes to meter per second, that is 5 by 18 meter per second. So here SI unit of speed is meter per second. So if we have given kilometer per hour, then we will change it into meter per second by multiplying by 5 by 18. But the 5 by 18, how it comes? It comes as kilometer to meter, it is 1000. Hour to second, it is 60. It is for 1 minute. So 60 for minute to second. So it is 5 by 80. So acceleration is here again of two types, that is uniform acceleration or non-uniform acceleration. So uniform acceleration is the acceleration if the equal velocity changes in equal interval of time. But in non-uniform acceleration, unequal velocity changes in equal interval of time. For example, if the body is falling freely, then it has equal change in velocity with equal interval of time. But if you are driving a car due to traffic, due to your personal reason, the velocity changes at different intervals. So there is unequal change in velocity. So that's why it is non-uniform acceleration. The motion of car is non-uniform acceleration. So next topic is graphical representation of motion. So here we have two types of graph, that is distance time graph and next is velocity time graph. So in distance time graph, so again there are two types of graph. It is for uniform motion and other is for non-uniform motion. So uniform motion is when equal distance covers in equal interval. Here you can see the equal distance traveled by the body in equal interval of time. So here you can see velocity changes, that is d2 minus d1 upon t2 minus t1. That is distance 1, distance 2, time 1, time 2. So we can calculate velocity from this distance time graph for uniform motion. On other side, you can see the graph is not straight, it is curved, but it is moving upward. The slope is upward. So it is the distance time graph for non-uniform motion, but it is accelerated because here the body motion of the body increases. For deceleration, the body of the motion of the body decreases. But here you can see the body remain at the same position but the time changes. So we can say that body is at rest. So here velocity is 0. Why velocity is 0? Because here you can see the distance, both distances are same. If d1 minus d2 is same, then it is 0 by d. So 0 by d means v equals to 0. So here it is the distance time graph. So next is velocity time graph. In velocity time graph, it is for uniform motion as the equal velocity changes in equal interval of time. Equal velocity changes in equal interval of time. Here it is the increase in velocity, so it is accelerated. But here velocity remains the same. It is for the object moving with same speed or uniform speed. So object is moving with uniform speed. So you can say that A is 0. So why A is 0? Because V are the same. So V2 minus V1 is 0. So A comes out to be 0. So velocity time graph and distance time graph are helpful to calculating acceleration and velocity respectively. So we can do the numericals related to these formulas. So let's start. So now start the numericals. So first numerical is a car traveling with speed 20 km per hour and comes at rest in 0.5 hour. What will be the acceleration? So here a car travels with speed 20 km per hour, which means it is its initial velocity or initial speed, that is u. It is 20 km per hour. Comes at rest. After completed journey, it comes to rest. Its final velocity speed, that is v, which is 0 km per hour, because it is at rest. In 0.5 hour, it is time. Time taken for a journey is 0.5 hour. Here, initial velocity is greater than final velocity. So we can see that v is less than 0. When v is less than 0, it is called retardation or negative acceleration. So acceleration is change in velocity upon time. So v is 0 minus 20 upon 0.5. So it is minus 20 into 10 upon 5. So it is 5 4. It is minus 40 kilometer per hour square. So we can say that it is, what it is? It is retardation. So it is retardation. So clear? So next is a car speed increases from 40 to 60, which means initial velocity is 40 km per hour and the final velocity is 60. Final velocity is 60 km per hour and the time is 5 seconds. So we have to change that kilometer per hour to meter per second. So how it is possible? 40 multiply 5 by 18, 60 multiply 5 by 8. So it is 11.11 meter per second. So it is 16.66 meter per second. You can calculate. So average speed is v minus u upon t. It is 16.66 minus 11.11 upon 5. So 6 minus 5. So it is 5.5 upon 5. It is 1.11 meter per second. So it is acceleration. I am sorry. It is acceleration. So it is acceleration. So next is first half of journey of a body with speed is 40 km per hour and next half travel in speed 20 km per hour. Calculate the average speed. So average speed is u plus v upon 2. So what is u? 40. Next is 20 upon 2. 60 by 2, it is 30. So it is 30 kilometer per hour. Is that clear? So next is a car traveled 20 kilometer in first half. So S1 is 20, it is distance. So here you can write distance is 20 kilometer. Time is first half, that is first half. Next is D2 40 D2 is 40 kilometer and T2 is second hour. Second hour is next first hour. 1 hour. D3 it is 30 kilometer, which is T3 is 1 hour. So we will calculate average. So S average is D1 plus D2 plus D3 upon T1 plus T2 plus T3. So it is 20 plus 40 plus 30 upon 1 plus 1 plus 1. It is 4 3 70. 70 plus 20 90 upon 3. It is 30. That is 30 kilometers per hour. So here are the numericals. You can try at home. I will attach some numerical in PDF file. So you can try at home. If you have any problem, you can connect. Thank you.